If you don't know anything about truth tables, you're in the right place. This will be a comprehensive beginner's guide. In this episode, I will go through the truth tables for the Boolean connectives, and, or, and negation. So here are the operators: logical, not, and, or. To begin with, a truth table is a tool that displays all possible combinations of truth values for a given sentence in an organized manner. It helps us to determine what is true or false in different situations. Before we begin drawing our tables, we need to know how many variables we have, since the number of rows is calculated as such. 2 to the power of the number of variables we're dealing with. So let's say that we have A and B. That is 2 variables, which means that we need 4 rows. But if we have, let's say, A, B, and C, it would be 8 rows, since 2 to the power of 3 equals 8. Just a quick tip. Whenever I see a logical sign, I sometimes whisper the name of it in my head. That way it all makes more sense. Like not A, for an example. Now, let's begin with the simplest one, and that would be negation. A negation is simply a denial of a proposition. In other words, claiming that something is not the case. Notice that the negation sign is not a minus sign. One might think it is the same thing, but they are very different. So let's begin by drawing up our tables. This one is simple, since we only have one variable, A. And what is 2 to the power of 1? Well, 2. So we only need 2 rows. So let's fill out the different possible truth values here. If we only have one variable, it can only be either true or false, right? So let's fill out those possibilities here. True and false. Then, if we have the negation, not A, in other words, they will always have the opposite truth value, right? Let's say that A means that I have a hamburger. Then, if it is the case that I have a hamburger, as it is in the case here, the negation of it is not the case that I have a hamburger, is false, right? And if it was the case that I didn't have a hamburger, then the negation is true. Does it make sense? In other words, the negation always reverses the truth value. So here we have the truth table for negation. Simple enough? Let's move on. Now to logical and, or as it's sometimes called, conjunction. A quick tip. To remember this symbol, I sometimes think that it looks like an A missing a line for and. So here we have a sentence, A and B, but let's make it more easy and concrete by switching out the letters. Let's say that A means that my friend will give me a hamburger, and B means that my friend will give me fries. So before we begin, we have 2 variables here, right? So that means 2 to the power of 2, which is 4. So we need 4 rows. Then, what we want to do is a fully exhaustive truth evaluation. In other words, test out each possible situation. So we simply begin by filling out these possible truth values. So here, we just write down true, true, false, false. And here, under B, we have to write it down in a different order so we can then test each possible scenario. So here, instead, we write down true, false, true, false. Now, the fun begins. Let's say that a friend of mine told me, when we get to my place, I will give you a hamburger and fries. Okay, here we have 4 different hypothetical scenarios. First one, we arrive at my friend's place and he gives me both a hamburger and fries. Then he told me the truth, right? He gave me exactly what he told me before. So then we write down true here. But then in scenario 2, he gives me only a hamburger. But then he lied to me, right? Because I would complain and say, hey man, you said that I would get a burger and fries, not just a burger. So if A is true, but B is false, that would make the conjunction of them false as well. And then in scenario 3, my friend gives me only fries. Same thing here. I would complain since he said that I would get both. So the conjunction is false. He lied to me. And lastly, in scenario 4, we arrive at my friend's place and he doesn't give me anything. What kind of a friend is that? Well, obviously then, the sentence is false. I would have felt that he lied to me. So here, we have the truth table for A and B. A conjunction is only true when all of the variables are true. So now, let's move on to disjunction, or logical OR, as it's called. Here is the logical symbol for OR, and the way I remember it is that it looks like a V for versus, if that helps. So let's stick to the hamburger example, but this time around, my friend tells me that I will get a hamburger or fries. Same thing here. We have 4 possible different scenarios. In the first scenario, my friend gives me both a hamburger and fries. Some might find this one odd, but in this case, it is in fact true. In standard logic, we commonly have an inclusive disjunction rule. So in other words, if both the disjuncts are true, then the whole sentence is true as well. But I'm curious, would you say that my friend lied to me when he said that I would get burger or fries, but then brought me both? Please leave a comment down below. I would love to hear your thoughts. Then, in scenario 2, he brings me only a burger. That makes the disjunction true, right? Burger or fries. One is enough to make the whole sentence true. In scenario 3, he brings me only fries. Same thing here. That also makes the disjunction true. And lastly, in scenario 4, he gives me nothing. But then, that is false, right? I mean, he said that I would get something, burger or fries. So this scenario is false. So here we have the truth table for disjunction. And it is true in all cases except when all of the variables are false. So here we have all the truth tables that we have discussed. Make sure to subscribe if you want to know more about logic or philosophy. Logic and philosophy. In the next episode, I'll go through the truth tables for conditionals and biconditionals.